Okay, so to continue with our discussion, so we now go to the second part of the trigonometric integrals, which is the transformation by trigonometric functions. So in this particular subtopic of your trigonometric integrals, we focus on these three types. So as you can see on your screen, so you have type A, type B, and type C. So type A is the combination of sine and cosine function with varying exponents per function. Same goes for your type B and type C. So tangent secant for type B with different values for their exponents. And type C is cotangent and cosecant. So in this topic, so I think what you need to focus on a particular identity is the Pythagorean or the Pythagorean identities. So I think that's what you need to um, focus on this topic. Okay, I think this particular identity requires special nga attention in breaking it down into a simpler or breaking it down or processing it sa iyang integration process. So for those of you who don't know the Pythagorean identity, so these are the three basic Pythagorean identities. Yeah, I think you're pretty familiar with these equations because muna siya magbalik-balik sa inyong trigonometry class. So sine squared theta plus cosine squared theta is equal to 1. Then tangent squared theta plus 1 is equal to secant squared theta. And lastly is cotangent squared theta plus 1 is equal to cosecant squared theta. So notice each equation will be used per type. So this is for type A, this is for type B, and for type C. Okay, so let's start with type A. So for type A, so there are two cases. So um, I think in each type, there will be two cases because if case number one doesn't apply in the situation given, so the other case will apply in the process. So for case number one, type A, so again, this is the sine and cosine tandem. So in case number one, if m or n is an odd and positive integer, so if you break down the first sentence, so if either m, that will be the exponent of the sine function, or n is an odd and positive integer. So if m is odd, so that will be the sine function. So we need to factor out sine u du. And then apply sine squared u equals 1 minus cosine squared u. So again, this equation is coming from the Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1. And then, i-rearrange lang siya, di ba? I-isolate lang ang sine squared theta. That's why it's sine squared u is equal to 1 minus cosine squared u. So if you wonder why it's theta and then the one I am presenting is in terms of u, so again, it's all dependent on the author. So the author could use any variables. So here, I think my reference is ang iyang variable is using the u parameter. So in most trigonometry books, the variable for the angle is theta. So it differs from the authors. So next, if let's say the cosine function has an odd exponent, so this time is you need to factor out cosine u du and then apply this Pythagorean identity equation, which is cosine squared u is equal to 1 minus sine squared u. So what do you mean by apply these equations? Okay, so let's say you are given sine cube x. So if we factor out, so again, notice that it's a 3 exponent. So if we factor out sine u du, so let's say, ana siya. So if we factor out sine u du, so this will be sine squared x. And then again, factor out sine u du. So this will be sine x dx. So this is the factored out term. And then the application of sine squared u is you apply it here, meaning you replace this one with this equation. So this will be 1 minus cosine squared u and then sine x dx. So I think the next process will be appreciated because you'll be using basic approach na, such as the u sub technique or other simplification process. All right, so for us to able to appreciate this, so we start off with the first example. So before we go to the first example, so any questions? Or I think you can probably understand it better if we try to solve the examples. So let's start off with the first example. So again, as per case number 1, so we need to look out for the exponents of the function, whether if it's an odd and positive integer. So notice as in the given equation, sine cube x or sine x cube times cosine to the negative 5x dx. So as you can see here, both are odd, but the cosine function has a negative exponent. So we focus here. So as per case number 1, so since the sine function has an odd positive integer, the exponent, so we need to factor out sine x dx or sine u du. So since here it's x variable, so we need to factor out sine x dx. So the dx part is already outside the equation. So what we need to do is we just factor out 1 sine x outside the equation for it to become sine x dx. Okay, so this becomes sine squared x, then cosine negative 5x. Then the outside factor sa parenthesis will be sine x dx. So first step has been done. So next is we apply the formula. Sine squared x is equal to 1 minus cosine squared x. So this becomes, so instead of parenthesis, so we change it to bracket because we will put the corresponding identity of sine squared x inside the parenthesis. So 1 minus cosine squared x and then cosine to the negative 5x and then sine x dx. Okay, so we further simplify this one. So distribute. So we're going to have integral of cosine to the negative 5x minus, so cosine squared, then cosine negative 5. So adding or multiplying terms having the same base but different exponents. So if you try to look back your exponent rules, so this becomes cosine negative 3x, and then sine x dx. So of course, we're not going to multiply back again this term here because again, we already factored it out, diba? So why do all the hassle nga magsige mo og kanang back and forth, diba? So since you already factored this one out, so you don't need to multiply it again or expand it again inside the equation. So this is the next part here. So we have cosine to the negative 5x minus cosine to the negative 3x sine x dx. So next part is we're going to do the u sub technique. So again, we won't be distributing this term here because it's already factored out as per first step. Okay. So first step. So second step is this one, applying the identity. So next is we do the u sub technique. So notice that this one is sine x dx. So if you're going to ask me what will be the proper way of using the u sub, so since we factor this one as sine x dx, so this will be our du later for our u sub. And of course, if you're going to think what particular function that gives a sine function nga derivative, so of course that will be the cosine function. Okay, so let u be cosine x. So the derivative of cosine is negative sine x dx, diba? Right? Now again, since this one is positive, so we just try to divide everything by negative 1. So this will be negative du is equal to sine x dx. So meaning this will be negative du, and then this will be u to the fifth, a negative fifth, u to the negative third. Right, so by replacing each term, so we now have u to the negative fifth minus u to the negative third negative du. So we can place negative outside the equation. So negative and then u to the fifth minus u to the third du. So this is a standard formula or basic formula. So u to the power of n plus 1 over n plus 1. So this will be, so integrating the first term. So this will be u to the power of negative 4 all over negative 4. Then don't forget the negative sign coming from the last or the previous line sa solution. So next is the next term na sad. That will be minus, and then minus pa jud because of the negative sign, u to the negative 2 all over negative 2. Diba? Ang formula is u to the n plus 1 all over n plus 1 plus c, diba? So plus c. So combining all the negative symbols, so this one is 1 negative, then another negative in the denominator. So this will give us a positive term. So this will be u to the power of negative 4 all over 4. Here is we have 3 negative signs. So this will be minus u to the negative 2 all over 2 plus c. So don't forget to bring back the value of the u parameter, which is cosine x. So our final answer would be cosine to the negative 4x all over 4 minus cosine to, to, uh, to the negative 2x minus 2 plus c. So this is your final answer. All right, so questions or clarifications regarding the first example? Okay, so I think there's none. So let's proceed with the next example. So we now go to the integral of sine to the power of 4 2x times cosine to the power of 5 2x dx. So notice that the exponent of the sine function is an even number. Then for the cosine, that's a odd number. So also notice that in this example, you have a coefficient for the angle. So I think we need to also to be careful in integrating later on because again, since it has a coefficient, so you need to apply the 1 over a in a formula. Okay, so this time, so since the cosine function now has a um, an odd exponent, so again we need to factor out cosine x outside the equation for it to become cosine x dx. So this becomes so usually I try to enclose the remaining terms inside a parenthesis para I know that I can focus on the terms inside and then the terms outside will be used later for the u sub process. So that's why magsige ko put og parenthesis so that I can clearly differentiate the parts of the solution. So sine to the power of 4 2x and then this becomes cosine to the power of 4 2x. Then again outside the equation is now cosine x dx. So again this is the factored term. So again you won't be trying to multiply it again back inside the parenthesis because we already factored it out and the factored out term will be used later on in the u sub process. So next step is we try to replace the factored out term with the corresponding Pythagorean equation, which is now, since this time it's cosine, so we need to replace the cosine squared with um, 1 minus sine squared 2x. So again, para di ko ma-confuse, I'm going to use brackets now. So sine to the power of 4 2x. So this, since this one is to the power of 4, so meaning there are two sine squared ma-replace, di ba? So meaning this becomes 1 minus sine squared 2x and then squared pa dyan, di ba? Para to the power of 4 siya. If we try to bring it back to the cosine 2x function. So cosine x dx. So again, for you to be able to distinguish, so let's try to write it in another color. So this becomes cosine squared 2x and then squared pa dyan, di ba? Then we replace this one with the corresponding Pythagorean or Pythagorean identity. So that's it. So again, this is the first step, factoring out. The next step is replacing it with the corresponding Pythagorean equation. So after you have done the first two steps, so I think the next part will be depending on the problem, whether you're going to expand it or you're going to simplify it directly. So this time I think we need to expand this term. Then before expanding it even further by multiplying sine to the power of 4 2x inside the parenthesis. So since we know algebra, diba? Difference binomial of squares, diba? Difference of two binomials, square. So this will be sine to the power of 4 2x, and then 1 minus 2 sine squared 2x, and then plus sine to the power of 4 2x, and then cosine x dx. All right. So distribute. So this becomes sine to the power of 4 2x minus 2 sine. So notice 4 and then 2. So this one is 6 now. Adding exponents with the same base, and then plus sine to the power of 8 2x, and then cosine x dx. So para di mo maglibog on my bracketing and then my the usage of brackets. So to give you a simple reminder, so first is parenthesis, and then next is bracket, and then lastly is braces. So I hope you can remember this one sa inyong high school Missouri, or sa ko, I think I learned this one from my elementary, so grade 6 na. Okay, so since you're now done expanding, so what we try to do next is we try to use the U sub technique. So again, this one is our kanang, how do you term this? It's already our DU. So automatically it's not DU because we probably na siya DU over 2 or negative something ana. Basta mo na siya tong DU sa U sub process. So nakalimot ko 2 diri. So dapat kuha na siya 2x, 2x. Okay, so let U be equal to sine 2x, because of course the corresponding answer for this one, or the corresponding derivative for sine, is cosine, diba? Which is our factored out term. So getting the derivative, so this will be cosine 2x. So again, since it's derivative, so we still need to multiply it by 2 because we need to derive the angle, and then dx. So for it to be completely the same as the factored term above, so we need to divide everything by 2. So this becomes du over 2, and then cosine 2x dx. So this term here is du over 2. And this one is u to the fourth, u to the sixth, u to the eighth. So the equation becomes the integral of u to the power of 4 minus 2u to the power of 6 plus u to the power of 8, and then du over 2. So you can just put 1/2 outside the equation. 1/2 integral of u to the power of 4 minus 2u to the power of 6 plus u to the power of 8 du. So you can now integrate and multiply 1/2 to each term. So this becomes u to the power of 5. So 2 times 5, that will be 10. So ako lang siyang i-shortcut because there's no space anymore sa screen. And then this will be u to the power of 7 all over 7. So there's no 7 because 2 and 2 will cancel each other out. And then plus u to the power of 8 all over 16 plus c. Hindi siya kuhaan eh. This will be 9 day. Kung na-shortcut ano. This will be so u to the power of 9. Then 9 times 2 is 18 day. And then since there's no more space, so just try to continue it on your own by replacing the u parameter back in the equation. So that's the final answer. All right, so questions or clarifications? So I think there's none. So try proceed to the next type. I mean case. So this is case number 2. So still type A. So again, ano siya? So in this case, if the given equation for the tandem of sine and cosine function, so this time are both, so notice that they are both, so both m and n are even and positive integers. So in case number 1, so we try to look out for one particular odd exponent for either term. Probably it would be the sine function or cosine function. But this time in case number 2, so we need to look out for both m or n. So it could be both functions could be having even positive integers, or it could be either just one. It could be either m only and then there's no cosine function presented, or the other way around. So if this is the case, if we have positive integers, so we need to factor out sine u du and then apply this term. So marag na kuhan na kung PowerPoint, no? So I think the other one here, if n is odd, I mean if n is even, day. So ang marag sahip ni siya da. So then use positive. So I think wala na siya labot. Kaya ako naman siyang i-copy paste there. So I forgot. So I think the sentence ends here. So if both are even positive integers or 0, so use these expressions accordingly. So if you try to recall this expression here, so these are the half angle identities. So maglain lang yan pagka-present, but I think they are the same lang jud. So if you try to katong akong discussion pag last meeting, so this will be sine squared theta over 2. So I'll try to give you a variation of the half angle. So it could be 1 minus cosine theta all over 2. So another variation of this one is sine squared theta is equal to 1 minus cosine 2 theta over 2. So this is the case here. Kani siya kaning given nga kuan. Muna siya ang but in terms of view lang. So another variation of it is katong sine theta over 2, then square root of 1 minus cosine theta over 2. Or if you don't want the theta over 2 expression, so you can have sine theta is equal to the square root of 1 minus cosine 2 theta over 2. So I think those are the four different variations of the half angle identities. So sine function lang akong gisuwat because for cosine, the counterpart of it is katong 1 plus cosine theta ra, di ba? Kani siya. So I think the difference is just the operation sign. So if sine half angle, that would be minus. If sine half angle, that would be plus. Then mana siya, the same variation. So kani siya different kanang kuan siya, different types or different variations sa inyong kuan, half angle. Okay, so probably let's try to use one half angle nga format. Okay, para di ta maglibog. So let's try to use this one lang siguro. Kaning presented on the screen. Kaning formula. So this will be kani siya. So usually I don't use the U aspect kay medyo maglibog ko. Okay, if I'm going to use this particular U here and then mag-use up pa ko later on sa ako ang equation. So daghan na kay U nga kuan, di ba? So muna ako lang siyang try to differentiate ang each process sa solution. Okay, so let's try to proceed to the first example. So the integral of sine squared 2x cosine squared 2x dx. So notice that both functions are positive exponents, positive even exponents. So since there are two types, so we try to use two different half angle equations. So one will be this term here, which will be sine squared theta is equal to 1 minus cosine 2 theta all over 2. Then the other one will be cosine squared theta is equal to 1 plus cosine 2 theta all over 2. So again, as per discussion last week, so we try to differentiate the different parts of the function. So to do that is we try to look at the formatting. So sine squared, and then 2x. So 2x will be the theta. Imong i-replicate ang given format sa formatting sa half angle identity. Okay, so meaning our theta is equal to 2x. So notice here we have a 2 theta on the counterpart sa inyong half angle identity. So meaning 2 theta is equal to 4x. So I think that's the same as the other variants katong theta over 2. So again, you just have to declare the different parts of the identity nga equation. Okay, so this one same here. So squared, and then 2x will be the theta. So theta is equal to 2x, and again, the counterpart of it is we have 2 theta, so multiplying everything by 2, so this becomes 4x. All right, so we can now replace the equation. So again, we replace it with this counterpart with its identity. So para di ko maglibog, so again, I'm going to use bracket first, then enclose this one with a parenthesis. So 1 minus cosine 4x all over 2. And then the next one is this term here. Then this is 1 plus cosine 4x over 2. And then dx. All right. So next is we try to multiply it. So multiply this one. So looking at the first or looking at the numerator, so this is the katong sa inyong algebra. So I forgot the term. I think it's difference of squares. Ang iyang product. So you may take 1/2 outside the equation so that you don't have to deal with the 1/2 later. So I think this is 1/4 there. So it's not 1/2. Excuse. So this will be 1/4 because 1/2 times 1/2 is 1/4. Then the integral of, so this one will be the difference of two squares because the middle term will cancel each other out. So 1 minus cosine squared 4x dx. So notice that we have another squared term, di ba? So meaning you have to repeat the process again. So you need to replace this one with its corresponding con. So again, we have theta is equal to 4x. So 2 theta is equal to 8x. So giving it a new equation now. So this is 1/4. So mag-ilisis lang color ha para kita nyo ang different steps. And then bracket. So 1 minus 1 plus cosine 8x all over 2 dx. So expanding the inside expression, so this will be 1/4 integral of 1 minus 1/2 minus cosine 8x over 2 dx. So ako siyang gi-expand by multiplying the negative to the terms inside the parenthesis. So 1/2. So pwede mo siya mabuwag. 1/2 and cosine 8x over 8. I mean cosine 8x over 2. Then applying the negative symbol. So muna siya inyong answer. So I think this one is now integrable because each term are now basic terms na siya. So integrate this one by multiplying 1/4, integrate and multiply 1/4, integrate and then multiply 1/4. So the first one is 1/4 x, and then the next one is 1/2 x na po, di ba? So I think 1/4 times 1/2 is 1/8, so negative 1/8 x. And then this one is, so integral of cosine is sine. So this will give us 1/4 and then times, so ato lang ikuha ng 1/4, then times 1 over 8, then times 1/2, and then times sine 8x plus c. So notice we can combine this one. Similar terms. So I think you can also combine it ahead of time in this term here because you can have it as 1/2 na lang instead of mag-integrate ka manually each term. So you can combine terms ahead of time and then integrate later rather than sa akong ibuhat karon nga nag-expand ko una and then I combine them on the later part na. Pero pareha gyapon siya answer gyapon. Okay, so this becomes 1/8 x. 1/4 minus 1/8 is 1/8. And then this becomes minus, so 4/8 32, that will be 64. 1/64 sine 8x plus c. So this will be the answer. All right. So questions so far? Okay, so I think there's no question. Okay, so let's proceed with this example. So again, it could either be both or either kanang one expression has an even exponent. So in this case, it's only the sine function. So of course, it's to the power of 4. So as per formula, so using the half angle, so sine squared theta is equal to 1 minus cosine 2 theta over 2. So since again this one is to the power of 4, so we can try to differentiate it as sine squared 2x and then squared, diba? We can do that so that we can try to replace it with this function. So again, notice that we have to identify the different parameters. So sine squared, so this is the corresponding format, and then theta is 2x. So theta is 2x, so meaning 2 theta is 4x. So and 4x will go to this corresponding identity. All right. Okay, so the next step is we try to apply the half angle identity. So we now have 1 minus cosine 4x all over 2 and then squared dx. Okay, so next is we have to expand the term. So this becomes the integral of 1 minus 2 cosine 4x and then plus cosine squared 4x. Then again, since it's squared, that will be over 4 dx. All right. So if you try to separate the terms, the fractions, so you're going to have 1/4, then minus, so 2 over 4, that would be 1/2. So we have cosine 4x all over 2, and then plus cosine squared 4x all over 4. So notice that the first two terms can be integrated because these are just simple equations now. You can just apply the formula-based equations. But for the third term, so we still have to do the um, another cycle of case number 2. So again, this will be the theta. So theta is 4x. So 2 theta is 8x. Then we have to apply the formula. Okay, so I'm gonna write it here. So upper right. So bracket because I'm going to place the third term inside the parenthesis. So 1/4 minus cosine 4x over 2 and then plus. So cosine function is the corresponding identity is 1 plus cosine, diba? 1 plus cosine 2 theta. So 2 theta being 8x all over so we have to multiply this one by 1/4 pa. Ano siya? Kaya wa siya ilabot. And then dx. Okay, by expanding it even further, so we now have 1/4 and then minus cosine 4x over 2 and then multiply 1/4 inside the parentheses. That would be plus 1 plus cosine 8x all over 8 and then dx. So the third term can be separated into two fractions. So you can have it as 1/4 and then minus cosine 4x over 2, then plus 1/8 plus cosine 8x over 8, and then dx. So 1/4 plus 1/8. So if you do the basic math, or I think you will be using or adding manually fractions because I think in the midterm exam you cannot use the calculator. So 1/4 plus 1/8. So that would be 3 over 8. So 3/8 minus cosine 4x plus cosine 8x over 8 dx. So again, integrate each term. So final answer would be 3/8x and then minus, so integral of cosine is sine, so this would be sine 4x, so over 8. So it's over 8 because it's 1 over a, that's 1/4 times 1/2, that's 1/8. And then we have sine 8x all over, so 8 times 8, that would be 64 plus c. So this would be the final answer. Okay. So questions? Sige, so question? Wala na eh. Okay, so I think we can proceed. So let's go to type B. So we're going to have um, another two cases for type B. And again, it will be based on the Pythagorean identity, which is um, tangent squared plus 1 is equal to secant squared theta. Okay, so if n is positive integer, that would be the exponent of the secant function. So secant, secant, so I think those are the different pronunciations as far as I know it. So you can call it secant, you can call it secant. Okay, so again, this is coming from the identity of tangent squared plus 1 is equal to secant squared theta. So as you can see, murag gi-kuha lang siya, di ba? Gi-reverse lang siya. So in case number 1, so I think what we need to observe is just the exponent of the secant function, which is n. So if n is even and positive integer, so we need to factor out secant squared du, and then use the corresponding formula for secant squared, which is this one. Okay. So in this example, so I think we can answer this one. So notice that in the given equation, so we have the integral of secant squared u du divided by the square root of tangent u. So notice that we already have the factored out term as secant squared u du. So I think what we need to do here is we just apply directly the equation, or I mean, since again it's already factored out. Low, mic test na day. May nawa akong mic. Okay, so again, since it's already factored out, so our next step, so usually if you get into the factored out term, the next step is always to use the u sub. So I think if you try to review the recording later, so after the first two steps, katong pag um, identify sa exponent, and then after getting or factoring out the corresponding formula and then applying it, is the next step would be kuan, di ba? So I think this is step 1, ang pag-factor out. And then step 2 would be the applying of the Pythagorean katong equation. But since we don't have any extra nga secant squared nga term, so we cannot use the formula nga katong kuan. Katong secant squared u is equal to 1 plus tangent squared u. So again, since there's no extra term, so we can just opt this one out. Okay? So pwede na siya wala. Okay? Kaya wala tayo extra nga secant squared diri. So third step is now the u sub. Okay, so again, since this is the factored out term, and again, as if you try to review the first type, ang katong factored out term is usually the du parameter. Okay? So let u, and then again, since we try to create a du of secant squared, so from derivatives, So we know that the derivative of tangent u is secant squared u du. So this becomes the u parameter, this becomes the du parameter. So next is we have the integral of du all over square root of u. So by exponential form, so this becomes u to the power of negative 1/2 du. And this is now integrable because it's the basic format. So we can just use the basic formulas by adding 1 to the exponent. So u to the power of n plus 1 over n plus 1. So u to the power of 1/2 all over 1/2, diba? So negative 1/2 plus 1, that's 1/2 plus c. So bring back the value of the u parameter, which is tangent. So we now have tangent u to the power of 1/2 all over 1/2 plus c. So final answer would be 2 square root of tangent u plus c. So this is the final answer. Okay. So questions? So I think muna na sa inyong ikuha dyan sa mga rules. So factor out and then apply the particular identity sa inyong kuan. Usually, katong again, the factored out term is always the du later sa inyong u sub. So again, if you try to review this recording later, so na yun na makita na ang katong factored out term is always the du term sa u sub. Alright, so let's go to the second case of the type B equation. So this time is we try to focus our attention on the exponent of the tangent function, m. So this time if m is odd and positive, so we try to factor out secant u tangent u. And then use the corresponding identity, which is tangent squared u is equal to secant squared u minus 1. So again, earlier in case number 1, we observe the exponent of the second function, which is the second function should have an even exponent, even and positive exponent. This time we go to the tangent function, case number 2. So the exponent for the tangent function should be odd and positive. Okay. So let's go to the example. So we have the integral of tangent cube x dx divided by the cube root of secant x. So again, as per first step, we need to factor out. So factor out secant u tangent u, diba? So here, sec u tangent u. Oops. Um, okay, so if we try to factor out secant u tangent u, so para di kita maglisod og factor out because we will be factoring out also secant. So let's try to create terms in exponential form. So tangent cube x, and then the cube root, we can express it as secant x raised to the power of negative 1/3, diba? So I think that way we can easily factor out the terms that we need sa atong first step. Okay, so again, factoring out secant u tangent u, so bracket, para di ta maglibog, and then secant x tangent x, diba? As per definition. So again, this will be the du later on, secant x tangent x, because again, from derivatives, we know that the derivative of secant is secant x tangent x, diba? So since we got one tangent outside the equation, so instead of cube, this becomes tangent squared x. Now this time our problem is this one, diba? So secant x. So since we got one secant x, yeah, it's negative pa jud. So negative 1/3 minus 1, this will be negative 4/3. So nag-guess rin ninyo? So let's try to write it ha. Okay, so there it's 3 minus 1, diba? It's 2. There it's negative 1/3 minus 1. That would be negative 4/3. Yeah, mo ni siya dire. So nakaguess mo? So ana ha? So again, we subtracted 1 because we factored it out. Secant x tangent x. So para ini-multiply na to, it reverts back to its original form, which is this equation. Diba? So if you try to multiply it again here, dapat ang yung given equation is this one, the original equation. Okay, so next is we replace tangent squared, diba? Sakto ba? We replace tangent squared. Okay, so replace tangent squared with, so this becomes secant squared x minus 1, and then multiplied by secant x to the power of negative 4/3. Okay, and then secant x tangent x dx. So we can try to expand this one by multiplying this term here to each term inside the binomial term. Okay. So the first term, secant squared x multiplied by secant x to the power of negative 4/3. So this would be secant, so ako lang yan secant x, oy, sex na noon. Sorry. So this would be secant x, okay. So 2 minus 4/3, so this will be 2/3 gyapon. 2/3. So I hope you know you know how to subtract or add fractions. And then minus the next term, which is just times 1. So we have to replicate the same term, secant x. to the power of negative 4/3. And then secant x tangent x dx. So since we have arrived at the point of kanang kuan, mag-use na ta. So again, diri ha, it's 2 minus 4/3. And it will be 2/3. So again, next is the u sub. So again, this is our du term here. So from derivatives, we know that the derivative of secant x, is secant x tangent x dx. So this one is the du. And this becomes u to the power of 2/3. The other one is u to the power of negative 4/3. So this becomes u to the power of 2/3 minus u to the power of negative 4/3 du. So it's another simple way of integrating using basic formulas. So plus 1 plus 1, this is u to the power of 5/3. Sakto ba? 5/3 pa, no? And then minus u to the power of negative 1/3 all over negative 1/3 plus c. So we have 3/5 u, 3u to the power of 5/3 over 5. Then since both are negative, this becomes plus 3u to the power of negative 1/3 plus c. So replacing back the equation, we now have 3/5 of secant x to the power of 5/3 plus 3 secant x to the power of negative 1/3 plus c. So this will be your final answer. All right, so questions? So I think there's no question. So just try to, again, review this recording as you answer the assignment that I'm going to provide also. So lastly is we go to the last type, which is type C. So there are still two cases. So as you can see, the type B and type C have a pattern because I think they are just relatable because tangent is just a counterpart of cotangent, diba? Vice versa. And secant with respect to cosecant. So for case number 1, we go to the cosecant term. So earlier in type B, the second function is positive, diba? But this time, the cosecant function is now the even integer na sad, the even positive integer na exponent. So factor out cosecant squared u du because we know by fact that in derivatives, the derivative of cotangent is negative cosecant squared u du, diba? And then we also have to use the corresponding identity, which is this one. All right. So in the first example, I'm sorry. So first example is that cosecant term is even. So we have to use the first case. So again, we need to factor out cosecant squared x dx. So by factoring out, so we have, so again, putting it inside the parentheses so that I can see the factored out term. So cotangent 3 4x, and then again getting 2. So this becomes squared 4x. And then again, the outside term is cosecant squared 4x dx. So again, the factored out term will be used later in the u sub technique. Okay, so we now replace the corresponding um, cosecant squared term. So this becomes cotangent cube 4x. And then this becomes 1. So I think it's minus 1 siguro, di ba? So I think it's not plus. So let's try to usang i-search ka dito. So plus na siya. So 1 plus plus na siya. And then cosecant squared 4x dx. Okay? So we can now expand by multiplying it even further or expanding it even further. So this becomes cotangent cube 4x for the first term. And then for the second term, this becomes cotangent to the fifth because that's 3 plus 2, 4x. And then the factored out term, which is cosecant squared 4x dx. So looking at the equation, so I guess there's no other way to simplify it even further, but now we can now use the u sub technique. Okay, so again from derivatives, we know by fact that the derivative of cotangent 4x, so its derivative, it's negative cosecant squared 4x. So again, don't forget that we need to derive the angle. So that's times 4 pa jud. And then dx. So since we're just interested in getting the du as cosecant squared, I mean, we only need to make it similar as cosecant squared 4x. So we need to divide by negative and by 4. So negative 4. So this becomes negative du over 4. Then the right side is just cosecant squared 4x dx. Okay, so I think you can follow, diba? So this one becomes negative du over 4. This becomes u cube. This becomes u to the power of 5. Okay, so simplifying even further after applying the u sub technique. So this becomes u to the power of 3 plus u to the power of 5. And then that's negative du over 4. So getting negative 1/4 outside the expression. So we have u cubed plus u to the power of 5 du. So negative 1/4 times u to the power of 4 over 4 plus negative 1/4 times u to the power of 6 over 6 plus c. So negative, that would be negative u to the power of 4 over 16, diba? 4 times 4 is 16. Plus minus, so this is minus u to the power of 6 all over 4 times 6, that would be 24 plus c. So final answer would be negative, that would be cotangent 4x, so raised to the power of 4 over 16, minus cotangent 4x raised to the power of 6 all over 24 plus c. So that's the final answer. All right. So last but not the least, this is the last case for the three types. So case number 2 for type C. So again, this time again similar to type B, we look at the m part, which is the cotangent function. So type B, that's the tangent function. Type C, that's the cotangent function. So same as the case number 2 for type B. So its exponent should be odd. And then we need to factor out cosecant u, cotangent u, and then use the cotangent formula, which is this one, cotangent identity, which is this formula. So again, we know by fact that the derivative of cosecant is negative cosecant u cotangent u, di ba? Okay, so without further delay, because we're almost out of time. So again, this is the m exponent, which is odd and positive. So the other one is a fraction, so of course, we go to case number 2. So again, we place it inside a parenthesis. So usually, para di ko maglibog, I try to reformat it on my own format para I can better understand it. So of course, you can use your own style basta as long as it's correct, di ba? So cotangent 4x, cotangent x to the fourth, and then this time is we have cosecant x. So take 1 from 4/3, that would be 1/3. And then cosecant x cotangent x dx. So again, if we try to expand it again, the given equation is equivalent to the first equation. Okay, so next is we apply the formula, which is cotangent, diba, is equal to cosecant squared minus 1. So notice that this one is to the power of 4. So we have to make another expression for this one. So this can be replicated as cotangent squared x and then squared pa dyan, di ba? Na. So by replacing it with its corresponding identity, so we have now cosecant squared x minus 1 and then squared, di ba? So again, this is what happened. And then multiplied by cosecant x to the power of 1/3. And then cosecant x cotangent x dx. Okay, so by expanding even further, so we now have cosecant to the fourth x minus 2 cosecant squared x plus 1, and then cosecant x raised to the 1/3 and then cosecant x cotangent x dx. So you may further expand it by multiplying cosecant to the 1/3 to each term. So this becomes, so 4 plus 1/3, so that would be 13, I guess, 13 over 3. So wala na, cosecant x 13 over 3 minus 2 times cosecant x, this one is 7 over 3, and then the last one is just plus cosecant x raised to 1/3, and then cosecant x cotangent x dx. So again, by u sub technique, because I think we cannot simplify it even further now. So let u be equal to cosecant x, and then the derivative of cosecant x is negative cosecant x cotangent x dx. And then divide everything by -1, this becomes negative du, which is equal to cosecant x cotangent x dx. So I think you can just continue with the solution. So just try to continue it on your own. Okay, kung ano siya, last part ang po siya. Okay, so I'll be posting the assignment probably after lunch because I still have a class after this one. So the same subject. So just post it mga after lunch. Okay, so for, of course, the assignment will be 1 week yapon. And then an allowance of 2 days for if dili makaya.